All right, so these are the 4 conversions that we discussed, right? So actually we didn't discuss, I just introduced you. There are 4 types of conversions. So first we went through the converting a decimal value into a non-decimal value, and we discussed how we are going to convert that, right? Dividing by the corresponding base, which we are going to convert, right? So later we talk about how to convert a non-decimal value into a decimal value. So we discussed that is when we are doing that conversion, we need the place values of the particular number, right? So if you are given with a value, so that value contains the characters, right? So each and every character is containing a particular place value based on their base, right? So it depends on the base of the number system. So if it is the example I got at the very first time is like we are using 10 base values. So the place values are created from 10 to the powers, right? 10 පාදේ සංඛ්‍යා අපි පාවිච්චි කරන්නේ වගේ ස්ථානීය ගැන තියෙන්නේ 10 බලවලින්, right? So likewise to the binary number system, there are place values in 2 to the powers, right? So we consider about the 2 to the powers, then we convert those into the equivalent values. So what we have done is we consider the place value and we convert and we multiply the place value from the symbol value, right, or the character value. So later we got add those things to have the final calculation or the final answer in decimal, right? So likewise, when we are converting binary into a decimal, we consider 2 to the powers. When we convert in octal into the decimal, we use 8 to the powers. When we convert in hexadecimal values into the decimals, we consider 16 to the power, right? So with that, I have given you the I have given you some questions to be done, and most of you have sent me the answers, right? So now I'm going to do these things and show you what are the answers, how the answers are going to generate, and then we can go for the next conversion method, right? Okay, so let me do that for you. So people who have done and have not get those things corrected, you can go with that, right? So let me take it. All right, so here we go. I'm going to do the first calculation, right? So I'm taking it like this. This is the answer 1. So we got 111011. This is in binary. Likira, I think you have done the calculations last week, right? Make a කරන්න දුන්න පුතා last week එකේ කට්ටියට. So if you have done, just check whether your calculation is correct. Otherwise, you can do the amendments, right? So we consider the place values like 2 to the power zeros, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, and 2 to the power 5, right? So we know the representation of these 2 to the powers. This is 1, this is 2, this is 4, this is 8, this is 16, and this is 32, right? So now what we are going to do is we consider the place value and the corresponding symbol value, and we are going to multiply those, right? So the answer is going to be generated like 32 into 1 plus 16 into 1 plus 8 into 1 plus 4 into 0. It is because like we got 0 above the 4, and plus 2 into 1 plus 1 into 1, right? So which is going to give us 32 plus 16 plus 8 plus 0 plus 2 plus 1, right? So now when you are adding these things up, so it's better you do it in a very keen manner, right? So you can easily add 32 and 8, which is 40. 40 plus 16 is going to give you 56. 56 plus 3 is going to give you 59, right? So your answer is going to be 59 in decimal, right? So if you got this correctly, please mark it, right? And if you got any errors with you, it's time for you to make those things correct, right? So I'll give you 1 minute, go through and do the corrections, if there is any. Right, so here we go for the second one. Yeah, my laptop battery is low. Thank you for reminding that. Right, so let me connect it to the charger. Yeah, thank you, Isara. Right, so the second question, 375 in octal. So this is answer for the second question. Right, so we know what to be done, right? So 375, the place values are going to be a to the power zeros, a to the power ones, and a to the power twos. So this means a to the power 0 equals 1, a to the power 1 equals 8, a to the power 2 equals 64, right? So this is going to be, now we are going to consider the place value and multiply it with the corresponding symbol value, right? So this is going to generate 64 into 3 plus 8 into 7 plus 1 into 5, right? So 64 into 3 is equal to 192 plus 8 into 7 is 56 and 1 into 5 is 5. So which is going to give you the answer. 2 plus 6 is 8, 8 plus 5 is 13, right? 1 is remaining. So 9 plus 5 is 14, 14 plus 1 is 15. So it's going to be 253, right, in decimal, right? And people, be very careful when you are doing the calculations regarding the number systems. do not forget to write the base. Always remember to write the base in any answer, right? So here comes the second answer. So just go through whether it is correct. If you got any corrections to be done, please have it. I'll give you 1 minute. Okay, so here I'm going to do the third one. So the third one is about C to D 16. So I'll do it right over here. So the answer for the third one, this is in hexadecimal, right? So the place values are going to be 16 to the power 0, 16 to the power 1, and 16 to the power 2. Right? Once you convert those into the corresponding values, it's going to represent 1, 16, and 256. Right? So as usual, we are going to multiply the corresponding place value with the symbol value, right? So that means 256 into C means what, people? A means 10, B means 11, and C means 12. And D means 13, right? Do not forget those, right? So you are going to multiply 256 with 12, not with C, plus 16 into 2 plus 1 into 13, right? So be very careful when you are doing the multiplication. Most of the people are like gone incorrect with this one because of the multiplication and addition errors, right? Now 12 into 6 is 72, 7 is remaining. 12 into 5 is 60 plus this 7, 67, 6 is remaining. 12 into 2 is 24, 24 plus 6 is 30, so 3072. Plus 16 into 2 means 32, and 1 into 13 means 13, right? So when you are adding these things, 2 plus 2 is 4, 4 plus 3 is 7, nothing is remaining. 7 plus 3 is 10, 10 plus 1 is 11, so 1 and 1 is remaining. So that 1 and the 0 of this 3072 is get added, so it will give us 1, and then 3 as the last number in the value. So this is going to give you 3117 in decimal, right? So please go through whether you have caught up the technique correctly and fill out the things, people. Right? I'll give you 1 minute to do your corrections. Then we are going to move to the next conversion. Meanwhile, people, do you got any questions? You can ask. Right, people, it seems you don't have any questions regarding this. I hope it is clear with you all. So let's move. Ranuja, අපි conversions ටික කරලා ඉවර වෙලාම පුතේ ඒ ගැන පොඩ්ඩක් බලමු. Right? Okay, so here I'm going to introduce you the next conversion. Right? So the next conversion, so far we have done 2 conversions, right? So first we have done converting the decimals into non-decimal values, and then we did the reverse, which means like converting non-decimal values into a decimal values. So today we are going to learn converting the binary values into octals and into hexadecimals, right? We are not going to convert them into decimals because we have done that already, right? So binary into octals and hexadecimals straight away, right? So let's write the heading converting binary values into their octal and hexadecimal. Let me just a second. Whiteboard එක පොඩ්ඩක් respond කරන්න නැතුව යනවා. Hexadecimal equivalence. Right, so write down the heading, people. Right, then let's talk about this. All right, now, first of all, to talk about this technique, I need you to take your attention to to the relationship in between binary and octal, as well as binary and hexadecimal, because it is the conversion that we do. We convert binary into an octal, binary into a hexadecimal. So if you think about the binary into octal, so like the relationship between binary and octal, we can represent it like this, right? So we know 8 is equals to 2 to the power 3, right? So that is the relationship in between octal and binary. So this is, we are representing 8 as a 2 to the power. So we can see 8 is 2 to the power 3, right? Now remember that, and you are going to see something related to that happens when we are doing the conversion, right? So the first example that I'm taking, right? So example number 1, this is about the binary into an octal conversion. So I'm saying convert 1 0 1 1 1, okay, 0 0 into its octal equivalent, right? So the task is given. So your task is converting 1 0 1 1 1 0 0 into a, this is a binary value, into an octal value. Now, how we are going to do this? Now, this is the method, this is the technique. Now, remember, this similar kind of a technique will be used to the conversion of the hexadecimal, like binary to hexadecimal thing. So, hear me out very carefully. This is a very simple, like this is the simplest, I think, the conversion that you can see in the conversion methods, right? So, first, what we are going to do is, we are going to take the number which is given in binary, and starting from your right hand side, we are going to divide this binary number, or like we are going to separate the characters of this binary number into a 3-bit groups, right? What do you mean by the 3-bit groups? We are going to create the groups from this binary value, which contains 3 numbers, or like the 3 characters inside it, right? We are start doing it from your right hand side, from your right end, right? So 1 2 and 3, here we are separating a group. Again 1 2 and 3, here we are separating a group, right? So now you can see the groups are being created, each and every group at least containing a 1 character. So like if you consider from your right hand side, the leftmost group has only 1 character, right? So if I can say, if this is the first group, this is the second group, and this is the third group, and the very last group contain only 1 character. So that is obvious because we can't change the value that is given to us. So when we are like separating the binary characters into a 3 group, like the 3-bit groups, eventually the very last group may contain 3 or 2 or 1 bit inside it, right? Yeah, people, is this clear what I have done so far? Can I have the confirmation, please?
Yes, sir.
Right, great. Yeah, Chanuri, yeah, Dua, what we have done is we have taken the binary value, the given binary value, and we start grouping the given value into a 3-bit group. That means the group which contains 3 bits inside it. Bits means 1 or a 0. So 3 bits means there will be like 3 ones or zeros, right? So it starts from your right hand side. Then from 3 by 3, you are going to group that, the number that is provided to you. Is that clear, Dua? Okay, great. So now the technique is, we consider these groups separately, and we think one particular group represents a binary value, and we convert that binary value into its decimal number. What are we going to do? We consider a one particular group, a group එකක් අරගෙන, we think it is a binary value, then we convert that binary value into its decimal equivalent. Make a binary value එකක් කියලා හිතලා group එකක් එයාගේ decimal value එක ගන්න. Right? So you know how to do that. It is the previous method that we use. Using the place values, we are going to convert that. And I'll show you a shortcut. Shortcut means actually a short way of doing this, right? Now, if you consider about the place value of the first group, it's going to be 1, 2, and 4. Why it is been 1, 2, and 4? Because the first place is 2 to the power 0, second place is 2 to the power 1, third place is 2 to the power 2. So which contains 1, 2, and 4. And if you consider the second group, it is again an individual binary number that we are going to consider. So that means, again, the first value is going to have 1, second going to have 2, third going to have 4. Right? And if you consider about the third group, we got only one symbol. So it is its place value is going to be 1. Is that clear, people? Everyone? So far, is it clear? Right? Okay. Now the game is almost over, right? So what are we going to do now? Now, trick is this. When you are finding the value, which represent by this small group, all you... Suhara, happy need that, and please go to Ami. Right, sorry for that, people. So now to get the value of a one particular group, it is very easy. All you have to do is consider the places or consider the place values which got a 1 above it. Neither place value එකට උඩින් එක තියෙන තැන් විතරක්. Right? Thank you, Rusira. Right? Place value එකට උඩින් එක තියෙන thang vitarak consider karan. Right? And do not consider the places where you got 0 above it. So this particular group contains, or like the answer is going to be 4, right? So earlier what we have done was like we calculate 4 into 1 plus 2 into 0 plus 1 into 0. Same happens. 4 into 1 is 4, 2 into 0 is 0, 1 into 0 is 0. So the final answer is going to be 4. So the same thing is doing here, but in a very shorter manner, right? So likewise, in the second group, what are the places that we are going to consider? The 2 and the 1, because those are the things, those are the places which has 1 above it, right? And I'm not going to consider the 4 because there is 0. So 4 into 0 is 0. So what is going to be your answer? 2 plus 1, which is going to be 3. So here we have to consider 1 anyway, because it is the only symbol we have. So it is 1. So your final answer is going to be 134 in octal. Yeah, people, is this clear? Can I have the confirmation? Right, okay. How about others? Right, great. Write this down, people. After that, we go for the hexadecimal conversion, right? So here we go. Let me know when you are done. Okay, Rusiri is done already. Others, please get it done as quickly as possible. You really don't need to write this 8 is equals to 2 to the power 3. I'm just illustrating to you, right? So I'll erase it. So just go with the example. Right. Okay. Is there anyone still writing this? Okay. So we are going to do the second one, the second example. Yes, Rusira, brilliant. That's the way we are going to do that. Right. So now we separate this particular binary value into the group of 3 bits. It is because 8 equals to 2 to the power 3. When 16 is equals to 2 to the power 4, we are going to separate a particular binary value into the group of 4 bits when we are converting binary into a hexadecimal, right? So the second example is about the hexadecimal conversion. So here we go. Example number 2. Convert the 1 0 1 1 1 1 1 0, and I'll put a 1 in front of, right? Into its binary equivalent. Right? So the task is simple. We know the drill now, right? So the requirement is converting 110 111, there are 5 ones, and 0 into a hexadecimal value, right? So what we are going to do is we are going to separate the
So in the
particular.
topic you are right, binary equivalent.
I'm sorry?
So in the topic you are right, binary equivalent.
Yes. I have written the incorrect word. I'm sorry. Thanks for the correction. So it's hexadecimal equivalent. Let me take out this hex well. Right. So what we are going to do is we are just taking the value. So starting from your right hand side, you separate this value into the groups which contains 4 bits. So 1 2 3 4 margin is drawn, and 1 2 3 4 the other margin is drawn, and there is a 1 remaining at the very last group. So what it's going to be the place value. So it's the same technique that we are going to use. So we consider this small group as a binary value, then we are going to convert that, right? So the place values are going to be 1 2 4 and 8, and this goes the first same way, 1 2 4 and 8, and in the very last group it's just 1. So this is the first group, this is the second group, and this is the third group. So same happens, but remember we are going to convert this into a hexadecimal, and if we find a value, whether it is 10 or greater than 10, remember to represent that from a capital letter as we discuss in the hexadecimal number system. So that means if you got 10, you are going to represent it by capital A. If it is 11, it's a capital B. If it is 12, it's going to be capital C. For 13, it's going to be D. For 14, it's going to be E. And for 15, it's going to be F, right? So here, how we are going to find the values, we are going to add 8 and 4 and 2, right? We are not going to consider 1 because there is 0 above that. So 8 plus 4 is 12, 12 plus 2 is 14. So 14, it is represented by E. So we are going to write E. Right, and in the second one, we are going to consider the 8, 2, and 1. We are not going to consider 4 because it got a 4 above that. So 8 plus 2 is 10, 10 plus 1 is 11. So 11, that means B. And here we are going to consider 1 anyway, so it is 1. So your final answer is going to be 1, B, E, in hexadecimal. Right, people, is it clear? Right, great. So copy it down, people. All right. Very good, people. You are like done with me. Good. Is there anyone still doing this? Yes, anyone? Okay, it seems everyone is done. Good, people. Good. Very good. So let's do some questions, right? So it's a question time. You know how to be like how you are going to give me the answers. I'll give you the questions. You send me the answers through the chat, right? Here comes the questions. Convert the followings into their octal and hexadecimal equivalence, right? So each and every value should be converted into both the values, right? The octal and the hexadecimal, right? So here we go. The first value is like 100,011 in binary. So I need the both octal and hexadecimal values. And the second one, 111,011,110, right? So I need both decimal and hexadecimal value. I'm sorry, both octal and hexadecimal value, right? Hurry up, people. Okay, someone has sent me the answers straight away. Okay. Yes, that is correct, Rusira. And Litira, both answers are correct. Risara, yes, that is correct as well. Yes, Litira, that is correct. Both the answers are correct. Very good. And in case Rusira, that's correct in hexadecimal, Risara, that's correct as well. And in case if you still not getting this, just let me know. I'll go through it again. Yes, Binadi, both the answers are correct. Well done. Tedhara, there is a problem though. Just go through it again. Ranuja, there is a problem again. Podak, go through Karana. Litira, yes, that is correct. That is correct. Gavindu, there is a problem. පොට්ටක් go through කරන්න දුව පුතේ දකුණු පැත්තේ ඉඳලා අපි වෙන් කරගෙන යන්නේ. Yeah, Tedara, yeah. The 43 is the correct answer. Yes, that's correct. Inupama, your second answer is correct, but not the first answer දුව. කලබල වෙන්න එපා. බලන්නයි. Pramod, hex answer is correct. Isira, both answers are correct. Risara, yeah, that is correct. That is correct. And Vinet, Puta, not that answer, Puta. There is a little problem. Go through that again. Tedara, yeah. First answer, the hexadecimal conversion is correct. Pramod, octal conversion is correct. Ranuja, octal conversion is correct. Hasita and Gavindu, octal conversion is correct. Gavindu, hexadecimal conversion is as well as correct. Rusira, yeah. Octal conversion is correct of the second question. right? And Anjana, yeah, both the answers are correct, Uda. Tedhara, yeah, that is correct. The octal conversion. Savidu, yes, that is correct. Very good. And Binadi, yes, both the answers are correct to her. Well done. Vinet, yes, that's the correct octal conversion. Metuli, Metumli, the same thing, same, the answers are correct. Answers are correct, Puta. Ranuja, yes, yes, hexadecimal conversion is correct. Risara, yes, that is the correct conversion. Keep it up. Yeah, Tedara, yes, that is correct regarding the hexadecimal conversion. Hasita, that is correct regarding the octal conversion. And Vinet, hexa conversion is correct. Rusira, hexa conversion is correct. Tisat, yes, first one is correct. Yes, Risara, there are only 4 answers. Yes. Tisat, yes, that is correct. That is correct. You can, Dilmi, you can directly write the decimal value doer, but in the paper, in the O-level paper, if they ask for you to do the workings or show the workings, it's better you show it in this manner, right? Otherwise, you can just directly write it, right? Gavindu, yes, yes, those 2 answers are correct. And Vinet, Anjana, those 2 answers are correct. Vinet, that is correct answer for the octal. And yeah, Metumli, yeah, hexa conversion is correct. Isara, hexa conversion is correct. Pramod, yeah, that is the correct answer of the octal. Pramod, yeah, that is correct, Uda, the octal conversion. All right. Metula. Yes, yes. All 4 conversions are correct. Ranuja, octal conversion is correct. Vinet, there is a problem with the hexadecimal conversion. Just go through it again. Vinet, we are not writing 13 as 13, Puta. We just represent 13 as D. Pramod, that is correct. Isira, that is correct, the octal conversion. Hasita, yes, that is correct regarding the octal. Vinet, yeah, that's the answer. That's the answer. Okay, so let me do these things for you. So if anyone has any struggling points, so it will be helpful to you to clear up the things, right? Yeah, Metumli, octal conversion is correct. Hasita, oh, Hasita, I think you mixed with B and D, I think, Dua. Hasita with Hasita, right? B එකයි D එකයි පැටලුණා කියලා හිතනවා, right? Yeah, so yes, Hasita, that's right. So this is easy, right? So I'm doing the first one. Pranuja, yeah, hexa conversion is correct. So what I'm doing is I'm just separating the groups from its right hand side. So these are 1, 2, and 4. The place values are 1, 2, and 4. So we can write this as 3. We can write this as 4. It is because Here we consider 1 and 2. Here we consider 4, right? So the final answer is 43 in octal, right? Yeah. So then for the hexadecimal conversion, so in hexadecimal conversion, we consider group of 4s. So it divide like this. So the place values are going to be 1, 2, 4, 8, and this is going to be 1, 2, right? Metumli, yeah, hexadecimal conversion is correct. Ranuja, I think I told you the hexa conversion is correct, right? So here we are going to consider the 1 and the 2, and here it's just 2, right? So your final answer, this is going to give you 3, this is going to give you 2. So the final answer is going to be 23 in hexadecimal. Right? So yeah, that's how it happens. And regarding the next one, it's 1 1 1 0 1 0 1 1 0. So here we are going to divide to represent the octal. So the place values are going to be 1 2 4 and 1 2 4 and 1 2 4, right? So how it's going to be, it's the 2 and 4 gives you 6, just 2 gives you 2, and all three things together will give you 7, right? So the answer is going to be 726 in octal. Simple as that, right? And if you are converting this into the hexadecimal, so it's again 1 1 1 0 1 0 1 1 0. So the separation is happening like this, right? Group of 4s, 4 bits. So the place values is going to be 1 2 4 8 and 1 2 4 8, and this is 1. All right. So it's going to be 2 and 4 in this group. It's going to be 6. And here it's going to be 1, 4, and 8. So 8 plus 4 is 12. 12 plus 1 is 13. 13 means what? 10, 11, 12, 13. A, B, C, D. Right? So it's going to be 13, which we are going to represent by D. This is going to be 1 anyway. Right? So your final answer is going to be 1d6 in hexadecimal. Right? So here we go. These are the 4 answers. Please do the corrections for the people who have not done the corrections. If you have done any mistakes, it's time for you to make that correct. Right? So I'll give you a minute. Please do the corrections. Then we can move to the very last conversion, and you will see it is easier than this. Okay. Is there anyone still writing or doing any corrections? Right. So let's move to the very last conversion. Right. So here we are going to talk about converting octal and hexadecimals into a binary equivalence. right? So that actually the reverse process of the above things, right? So let's have the topic. It's the fourth conversion. Converting octal and hexadecimal. Oh, what's going on here? Values into their binary equivalent. All right, now this is easy, people. Still, this got that relationship 8 is equals 2 to the power 3. Now, earlier, you can remember, we are given with a binary value. We group those binary number into the groups which contain 3-bit inside it. Now we are given the octal value and ask us to convert into the binary. So the thing we have to do is we take a one particular symbol from the octal value and we extract that symbol into a group which contains 3 bits inside it, right? කලින් කරේ 3 දෙනෙක්ව අරගෙන එක සංකේතයක් බවට පත් කරා. දැන් කරන්නේ එක සංකේතයක් binary වල සංකේත තුනක් බවට පත් කරන එක. Right? You will see it is very easy. Right? Okay, let me give you the very first example. So example 1. Convert 427 octal into its binary equivalent. Right? So what are we going to do? We take 427, which is the octal value. And now I'm going to write this as a 3-bit value. That means as a binary value. Each and every symbol of the octal value will be written as a binary value. Now, you can remember how we convert a decimal value into a binary. We use that particular conversion in here. And you can remember, like if we ask to convert 7 into the binary, we write 7, we divide it by 2, we say 3 and 1 is remaining, and 2, 1 and 1 is remaining. So we take this 1, 1, 1 and represent the 7. But here, I will show you a trick or very short way to figure out how to convert this particular symbol in octal straight away into the binary, right? You really do not need to go through these divisions, right? But you have to remember this. In this 3-bit value, we have the place value as 1, 2, and 4, right? Because we are going to write a binary value. So binary value has these 3 place values regarding the value that we are going to write. මොකද ඒක binary එකක්. So මේ place values ටික තියෙනවා. So now what you have to do is, using these values, just create the corresponding value. Then how you are going to create 7 out of these 3 values? You need 1 over here, you need 1 over here, you need another 1 over here. So 4 plus 2 is 6, 6 plus 1 is 7, right? So how we are going to create 2? You need 1 over 2 and you don't need anything over 4 or anything over 1. So that gives you 2. How we are going to create 4? 1, 0, 0. 4, 0. Right. Sorry for that roaring, people. So it's easy, right? So we consider the place values. We create the corresponding octal symbol, right? So how we are going to get the binary equivalent? So we have the binary groups now. So we write those binary groups in an order from left to right. So that means your final answer is going to be 1, 0, 0, 0, 1, 0, 1, 1, 1 in binary. People, is that clear?
So how you get 010 in 421?
Hold on. See, like this 0 and this 0, Buddha.
No, sir. The other one.
This one, like 0, 1, 0.
Yes, sir. Yes, sir.
Yeah. Now we are going to represent this 2, ne?
Yes, sir.
Right? So we are going to create that 2 using these 3 values, Buddha.
Okay, sir.
Right? So
Do you, so you get in the table on the our book?
No, yeah, there is a table kind of a thing in your book, but you really don't need to remember that. Just remember these values are there under your this particular structure. පොඩි මේ table එක යට මේ 4 2 1 තියෙනවා කියලා හිතා ගන්න. එතකොට ඔයා
Okay, sir.
කරන්නේ 2 හදන එක එකෙන්. ඒතකොට 2 හදන්න මෙතන 2 විතරක් තිබ්බම ඇතිනේ.
Yes.
Because of that, you can put 1 over here. So you don't need 4. When you are having 1 over 2, it represents 2. So you don't
Okay,
need
sir.
anything over the 0. You don't need anything over the 1. That's why you are putting zeros over 4 and 1.
Okay,
Got
sir.
it?
Thank you, sir.
Got it?
Yes, sir. Thank you.
Right, great. Yeah, Ranuja, in the method of division, so how it's going to be? So I have shown you 7 over here. So it's going to be 1, 1, 1, right? And you have to be very careful, like when you are dividing something like 2. So it's going to be 1 and no remainders, right? So you can write 1, 0 for 2, but our method is writing the particular octal value using 3 bits. So 2 represent karanna ඕන වුණාම we have 1 and 0, but we have to fill another 0 at its left because we need 3 bits to represent a one particular symbol of the octal. Right? And if you want 4 again, so you do the division. So 2 and no 0, you do the division again, 1 and no 0. So it's 1, 0, 0. Right? So the same answers that we written over here is given by this, this, and this. Is that clear? Right? Okay, Rusila. So Ranuja, yes. So you can write it from left to right, but this, like if you get used to this, the way I have done, it's very easy for you to write the answer, right? So you only need to remember there is this little table or a little boxes which has place values of 1, 2, and 4. So all you have to do is like using those 3 values, just create this particular value, right? So you have to create these values separately from that little boxes, right? Simple as that. All right, can we write this down? I think most of you have done with it, but yeah, write this down. And you don't, if you want, just this part can be written, and if you don't want, you can omit it, right? Okay, so is there anyone still writing this? Okay, it seems not. So I'm moving to the next example, right? So example number 2, here we are going to convert a hexadecimal one into the binary, so we know what is going to happen. When we are converting a binary into an octal, we consider a particular, when octal into the binary, we consider a particular octal symbol alone, and we return it using 3 bits. And when we are doing the hexadecimal conversion, you consider a particular symbol of hexadecimal alone and extract it using 4 bits, right? Because 16 is 2 to the power 4, right? So let me take the example. Convert ABC in hexadecimal into its binary equivalent, right? So we know what to do. We take A, B, and C and we write it in 4 bits. Now, what's going to be the place values for these 4 bits? It's going to be 1, 2, 4, and 8, right? So it's 1, 2, 4, and 8. This is going to be 1, 2, 4, and 8. And this is also going to be 1, 2, 4, 8. Now, since we are given the capital letters, it's better we write the values above that, right? So A is 10, B is 11, C is 12. So now what you are going to do, you are going to make these 10, 11, and 12 using these boxes, right? So let's first make C, that is 12, right? How we are going to create 12? We need 8, we need 4. 8 plus 4 is 12. So the thing is done. So we don't need 2's, we don't need 1's. You want to create 11. So you have 8 plus 2 is 10 plus 1 is 11. So we didn't use 4. And the 10, we got 8 and we got 2. 8 plus 2 is 10. And we don't need 4 and we don't need 1's. So now how we are going to write the equivalent binary value? So it's going to be, you are writing from left to right, 1 0 1 0 1 0 1 1 1 1 0 0. This is going to be your binary equivalent, right? Yes. Yes, Gavidu, that's going to be the answer. Yes. All right, people, please copy it down if you have not copied it down already, right? So then we can move to the questions. All right, two are done. Is there anyone still writing this? Okay, it seems everyone is done. All right, here comes the questions. Convert the followings into their binary equivalence. Right, from number 1, it's going to be 127 in octal. Roman number 2, it's going to be 7A9 in hexadecimal. 2 simple maths. So just fill it out, people. And you will realize, like, you will be having the zeros at the very left end, right? So you can omit those left hand zeros finally, right? So first you extract the things, then you disregard the leftmost zeros, right? Yes, Rusira, that's the answer, correct. Very good. Yes, Tedara, that's correct. Litira, yes, that is correct. Litira, hold on. Your hexadecimal conversion, just take a look at it again. And Risara, that is correct. Binadi, that is correct. Dilni, yes, Dua, that's correct. And Inupama, yes, that is correct. That is correct. And everyone who have done the first conversion, you can omit the leftmost zeros. One පැත්තේ කෙලවරේම තියෙන බිංදු දෙක අමතක කරන්න පුළුවන්. Right? මොකද ඒ දෙන්නට වැලියු එකක් නැති නිසා. හැබැයි කෙලවරේම තියෙන බිංදු විතරයි. Right? මැද තියෙනව අමතක කරන්න බෑ. Yeah, Metumli, yeah, that answer is correct. Gavindu, that answer is correct. Hasita, that answer is correct. Very good. And Isira, that is correct. Isira, hold on. Isira, පොඩ්ඩක් බලන්න පොඩ්ඩක් වැරදිලා තියෙනවා පුතේ. ආයෙ පොඩ්ඩක් go through කරන්න. Pramod, that answer is correct. Dilni, yes, that answer is correct. Dua, hexadecimal. Gavindu, that is correct. Risara, පොඩ්ඩක් බලන්න පොඩ්ඩක් එහෙ මෙහෙ වෙලා තියෙනවා මං හිතන්නේ. Right? Binadi, yeah, that is correct, Dua. Anjana, that is correct. Rusira, yes, that is correct. Metul, yes, that is correct. Isira, yeah, first one is correct, Puta. Tedhara, no, Tedhara, 7 people, hold on. Did I give it is 7A9 people, right? Okay, මොකද මට ඒක වගේ answers කීපයක් ඇවිල්ලා තිබුණා. 7A9 එක convert වෙච්ච විදිහ පොඩ්ඩක් වැරදිලා තියෙනවා. Tedhara, just see. Metul, yeah, that's the correct answer for the second one. Yes. Inupama, yes, that is correct as well. Dilmi, yes, that is correct. Pramod, first one. Pramod, the first one. නෑ ප්‍රමෝත් first one පොඩ්ඩක් පැටලිලා තියෙනවා මං හිතන්නේ චුට්ටක් ආයි go through කරන්න Delmi yeah second one is correct very good අතෙදාරා so පුතේ first one එකෙත් ගැටලුවක් තියෙනවා ඔව් චුට්ටක් go through කරන්න මෙතුම්ලි yes yes Yes, that is correct, Metumli. Malisha, yeah, both the answers are correct. Hasita, yes, yes, that is correct. And Anjana, second එක පොඩ්ඩක් වැරදිලා තියෙනවා පුතේ. පොඩ්ඩක් ආයෙ බලන්න. Yes, yes, yes. Right, Chamat, yeah, those answers are correct. Good, very good. ලිතිර මං හිතන්නේ ලිතිර ඩිජිට්ස් 4ක් පාවිච්චි කරලා තියෙනවා ලියන්න නේද? ඔව්. ලිතිර it's going to be 1 2 4 right? පොඩ්ඩක් බලන්න ඔයා 7 represent කරලා තියෙනවා හරි 3 bits වලින් 2 represent කරලා තියෙනවා වැරදි 3 bits වලින් 1 represent කරලා තියෙනවත් වැරදි පුතේ same goes with some others as well Tisat yeah that is correct and Anjana yes that is the correct answer Isira that is the correct answer Isira hold on there's a slight mistake puta පොඩ්ඩක් ආයෙ ගිහින් බලන්න Risara that's the correct answer Pramod, yeah, that answer is correct. Very good. Everyone, you are doing good, right? So please figure out the things that you are missing for the missing people, right? Others, you are doing very fine. Litira, yes, that is the correct answer. Himaya, yeah, that's the correct answer. Tedhara, yes, yes, those are the correct answers. Ranuja, yeah, that's correct, Pudha. Very good. All right, so let me do these conversions. Ranuja, yeah, Ranuja, I told you, that is correct. Those are correct. So let me show you the conversions. So 7, we are going to write those in 3 bits. සමහර අය මේක 4 bits වලින් ලියන්න ගිහිලා තිබුණා කියලා මට නිකන් හිතෙනවා. Right? So octal to binary, it's going to be the 3 bits thing, right? So 1 2 4 is going to be the place values, right? So 7 represents 4 plus 2 plus 1. That is how 7 works. 2, no 4s, 1 over 2 and no 1s. And 1, no 4s, no 2s, but 1 over 1. So your answer can be taken as 0 0 1 0 1 0 1 1 1. And you can simplify the answer by cutting down the very last zeros, right? These zeros. So you can take the final answer as 0 1 0, sorry, 1 0 1 0 1 1 1, right? There's no matter if you put it on the earlier manner. Maybe the tibba kila වැරදි නැහැ, right? But it can be simplified as I showed you in the latter part, right? So 7A9 goes the same way. Instead of 3 bits, here we are going to use 4 bits, right? So we got this. got this as well. So everything in 4-bit. So it's 1, 2, 4, 8. It's 1, 2, 4, 8. Again 1, 2, 4, and 8. Right. So it's going to be 9. How we are going to create 9? We need 8 and we need 1. So 8 plus 1 is 9. So other two places, it's going to be zeros. A means 10, right? This is 10. So how we are going to create 10? 8 plus 2 is going to give you 10. So other places are going to be zeros. So 7, it's going to be 4 plus 2 plus 1. So 0 is there on the 8. So the answer can be written starting from 0. So it's right from your left to right. So 0, 1, 1, 1, 1, 0, 1, 0, and 1, 0, 0, 1. And this 0 can be disregarded. So you can write the answer 1, 1, 1, 1, 0, 1, 0, 1, 0, 0, 1 in binary. Simple as that. Okay, so people, if you got anything wrong, just it's time for you to make that correct. Right, and if
So
you
we
got
don't cut the 0 also, no?
but didn't get you, Buddha.
Can we like we cut 0?
Yes, so it's like only the leftmost one. Right?
Okay.
You can't cut the things in between. Hari?
Okay.
Right. So, yeah. Okay. So if this is done, we can jump to our textbook and see what are the things we are left with. Any questions regarding these people? All right, it seems no questions. Okay, so let's go to the textbook. Okay, do we? Okay, no, right, okay. So here we go to the textbook. All right, so regarding the third lesson, yes, we have done all the conversions. We talk about most significant and least significant bits, digits, and everything. Yes, we have done. The conversion happens. Now we are expert on those. And what else we got? So yeah, we represent the, yes, this is also done. And this is a table that some of your friends have been asking, right? Then mamme table එක දෙන්නේ නැත්තේ like hexadecimal උනොත් ඕගොල්ලෝ මේ රටාව ඔක්කොම මතක තියාගන්න ඕනේ. Right? I think it's something in vain, right? So just stick to the logic, right? You will given the chance, like you can do any kind of extraction using that, right? All right, so yeah, that will be much easier. And we are in the very end, people. So okay. Yeah, then you are going to talk about the data storage capacity. So I'm not going to start it today, right? We are going to talk about these bits, bytes, kilobytes. We got something called nibble, but we are not using that, right? And we get to know how these things have been related with each other, and how the storage is arranged. And then after, we have to do the coding systems, which is called the BCD, ASCII, EBCDIC. Then we are done, right? So I think most probably by next week, we will be able to done with this session, right? So today I'm going to end the session like 2 minutes earlier, right? So next week, I'm going to see you with the rest of the part. So hopefully we will be able to finish up the the lesson which is left over, so we can move to the fourth one, right? So thank you very much, people. Have a very good night. Yeah, dear me, there is no conversions in between octal to hexadecimal doer, but it is very logical to ask that question, right? But if you want to do the conversion from octal to hexadecimal, there are ways that you can go. First, you can convert the octal value into the decimal, then you can convert decimal into the hexadecimal, right? You know how to do that two conversions. Or otherwise, you can do octal into the binary, then binary into the hexadecimal, likewise. Next week is a poet day. But let's do the class near the people. The poet days were keep a classes missuna. If we, I'll drop you a message after a discussion with the institute, right? Then I'll let you know for real, right? Okay, so thank you very much, everyone. Have a nice weekend and be safe, right? I'll see you on next week for the very same time, right? Thank you very much and have a good night, people. Thank you.
Okay, sir. Thank you, sir. Good night, sir.
Right, okay.
Thank you, sir. Good night, sir.
Thank you, sir. Good night. Right, okay. Right, okay. Good night.
Thank you, sir. Good night, sir, and stay safe.
Good night. Good night. Stay safe, people.
Thank you, sir. Good night, sir. Stay
Right,
safe.
okay. Okay. Good night. Good night. All right, Mithumli. Good night. Thank you very much. Okay, Himaya.